Hello guys, it's your science teacher, Teacher Thant, and welcome back to Science with Stanley. Okay, so the video lesson today was created to blow away all your confusions about naming chemical compounds in IGCSE Chemistry, because naming chemical compounds and writing down formulas of different compounds, it has always been students' greatest fear and confusion, and some students don't get it right until the very end of your exams, okay? But not after today's video, okay? So let's get ahead. Alright, so to be able to name any ionic or covalent compound correctly at any time, you only need to learn two things. The first one is the charges from the periodic table, and the second one is the charges from polyatomic ions. Okay, so I'm sure you've heard of charges from the periodic table. You might not be familiar with the green one, but you already are, and I'll just explain to you very simply what polyatomic ions are. Okay? Alright, so let's just look at the one that you already know, which is charges from the periodic table. Now, if you look at the periodic table, you must be able to draw a line where it differentiates between metals and non-metals. Okay, all right. If you draw a zigzag line, okay, a staircase here, what you should know is everything on the left-hand side of it are all metals, while everything on the right-hand side of it are called non-metals. Alright. Now, in metals, what you should know is group 1. There's group 1 and group 2 as written here. Okay? So these are metals, and group I wouldn't say 3, okay? So this section, okay? All of those section here is called transition metals, which will have a slightly different naming system than your metals. Okay, so this is transition metals. Alright, so transition metals don't actually have a group name because their properties vary from time to time, so we're not going to talk about it for a moment. But the charges from the periodic table, you should know that group 1 has a charge of +1, group 2 has a charge of +2. Now group 3 has a charge of +3, and then group 4 has a charge of +4, but group 5 has a charge of -3 because group 5 elements want to gain 3 electrons to get stable electronic structure. Okay, in a similar way, group 6 will have a charge of -2, group 7 will have a charge of -1, which are your halides, okay? Fluoride, chloride, bromide, iodide, astatite, okay? These will all have a charge of -1. Now, if you got this, let's go to the polyatomic ions. Now, if you spend 5 minutes per day or 10 minutes per day, okay, just to read this polyatomic ion and their charges, there's no way that you are not able to remember this, okay? So please spend some time on this. For example, carbonate is CO3 2-, sulfate is SO4 2-, sulfide, chromate, dichromate, and peroxide. So these will be used as sodium carbonate, potassium sulfate, and so on. And we've also got nitrate, nitrite, hydroxide, cyanide, permanganate, bicarbonate, phosphate, phosphite, and the only positive polyatomic ion, NH4+. Now, what is a polyatomic ion, you might be wondering, okay? It's very simple. So, Cl-, Br-, I- are all ions, but they only got one type in their ion. But poly means more than one or many, okay? So if you look at this right now, CO3 2- involves C and O, so it's more than one. That's why it's called polyatom, many atom or more than one atom ions, okay? So please learn this by heart if you don't want to confuse yourselves anymore in the future, okay? But if you don't want to spend time on this, chances are you will still be confused when you see compounds whenever you study chemistry. Okay, so you will notice that all of these on the left side will have a charge of 2 minus. The middle ones will have a charge of 1 minus, and phosphate and phosphite will have a charge of 3 minus, and NH4 has a charge of positive 1. Okay, again, I would like to encourage you to take time and study these by heart. It will definitely help you in your science career. Okay? Now, a simple strategy to name any compound is first, identify the type of compounds. Now, you've learned about ionic compounds and covalent compounds, and you know that ionic compound consists of one metal and one non-metal, and covalent compounds are composed of non-metals only. And this is the information that you need to recognize. For ionic compounds, you need to balance your charges such as +2, -3, so you have to multiply this with 2, you have to multiply this with 3 in order to get 0. Okay? But for covalent compounds, you do not need to balance your charges. Okay? Remember, you do not or never required to balance your charges at all. Alright, so let's go ahead. Now, first of all, let's take a look at ionic compound without transition metal, meaning that we're going to talk about all the metals except the ones in the middle. Okay? So if you have ionic compounds without transition metals, it's very simple because you simply write a metal name and a non-metal name, but you need to balance your charges. Let's see, calcium oxide, right? So if we see this calcium oxide, what we would do is calcium is Ca, and it has a charge of 2 plus because why? It is in group 2. And oxygen is in group 6, so it has a charge of 2 minus, so this is O2 minus. Now you do not need to multiply anything with anything, so because it's already balanced, so it is simply calcium oxide. Okay, CaO. For magnesium chloride, let's take a look at this. Okay, so magnesium chloride, Mg is in group 2. Okay, so it has a charge of 2 plus. Chloride ions is in group 7, so it has a charge of 1 minus, meaning that your formula is going to be Mg. Now CO, we have to multiply this with 2 to balance out 2 plus. So it will become MgCO2. Now aluminum fluoride, okay? So let's take a look at this. Aluminum is in group 3, okay? Right here. So we know that aluminum has a charge of 3 plus, and fluoride has a charge of 1 minus. So your formula would be AlF3. Now cesium sulfide. Cesium is in group 1, so it's simply Cs 1 plus, and sulfide is, where is it? It's here. Okay, so it has a charge of 2 minus. So it is simply Cs, and then you have to multiply this with 2 in order to balance your formula. So it will be Cs2F. Now try it out for lithium nitride and Google the correct answer for yourself. Now we take a look at ionic compounds with transition metals. Okay, so again, the transition metals, their charges are varying from time to time. Okay, so that's why we call them transition metals. Now, copper 2 chloride. If it is copper 2 chloride, it will be name of the transition metal, and then it will have a Roman numeral and a non-metal which ends in IDE. Please take note that the Roman numeral represents the charge that you have in front. Okay, so copper 2 chloride means that copper has a charge of 2 plus, and chloride as usual will have a charge of -1 because it's in group 7. So it will be, you have to multiply CO with 2 in order to balance it, so it will be CuCO2. Now how about iron 3 bromide? Similar to before, the Roman numeral will be representing the charge on iron. Okay, so iron 3 bromide will be Fe. Since the Roman numeral is 3, it will have a charge of 3 plus, and bromide is Br minus. So we have to multiply minus 1 with 3, so there should be FeBr3. Manganese 2 oxide. Manganese is Mn, and the Roman numeral represents the charge for the element in front, so it is 2 plus, and oxide is 2 minus as well because it's in group 6. Okay, so your formula is simply MnO because it is already balanced. Now, ionic compound without transition metals, but with polyatomic ions such as sulfate, chromate, sulfide, and so on. So let's see, potassium sulfate, right? So potassium is in group 1, so it's simply K plus. Sulfate, if you study the polyatomic ions, you will know that it is SO4 2 minus. So we need to have 2 of K, okay? So that's why the formula is K2SO4. Sodium cyanide, sodium is in group 1, so this is simply Na1 plus. Cyanide is Cn minus 1. So you don't need to multiply anything, you just simply write sodium cyanide. Now calcium hydroxide, calcium has a charge of 2 plus and hydroxide has a charge of minus. So you need to multiply this with 2, the entire thing with 2, okay, in order to get calcium hydroxide. So your formula would be CaOH twice. And last one, magnesium carbonate. Magnesium has a charge of 2 plus and carbonate has a charge of 2 minus because it is CO3 2 minus. So your formula would be MgCO3. You don't need to multiply anything. Now, if you look at this, you will notice that now you definitely need to go back and study the polyatomic ions by heart, because if you don't, how else will you write it? Okay? Now, ionic compound with transition metals and polyatomic ions. Now we want to talk about what happens if we combine these transition metals with polyatomic ions. It is pretty simple, okay? So copper 2 nitrate, right? So it's copper Cu. The 2 represents the charge in front, so it's 2 plus, and nitrate is NO3 minus. So we're going to multiply this entire thing with 2, okay? So that it becomes minus 2 and plus 2 to balance. So it will be Cu NO3 twice. Now iron 3 sulfate, okay? Pay attention to this. Since it is iron 3, we know that the charge on iron is 3 plus and sulfate is SO4 2 minus. So in order to balance this 2, what we need to do is multiply 3 plus with 2 and multiply 2 minus with 3. And in that only way, we will get plus 6 and minus 6 to balance them out. So our formula would be Fe2SO4 thrice. Okay? Make sure that you do this by yourself again one more time, okay? Because students tend to make mistakes all the time on this. Now, manganese to phosphate, okay? So manganese is Mn, and 2 shows the charge on this, so this is plus 2. Phosphate is PO4 3 minus. Now, how would you do it? You would try to multiply this with 3, and you would try to multiply this with 2 in order to balance yourself, okay? So your formula would be Mn3 PO4 thrice, okay? Make sure that you practice properly, okay? Alright, so again, ionic compounds, you need to balance your charges all the time. And the Roman numeral represents the charges in front. And then you need to study what the polyatomic ions charges are, or else you won't be able to write these, okay? Now moving on to covalent compounds. They are pretty simple because you don't need to balance your charges. Remember this all the time, okay? Because I've seen students who are trying to balance charges so hard and they get it wrong unnecessarily, okay? So, but what you need to study is the prefixes here, okay? Which is very simple. One is mono, okay? And it goes down. So it's mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca, okay? It is represented by 1 to 10. So we're going to add one prefix before the non-metal and another non-metal, which will end with IDE. Now, if it is sulfur trioxide, it is simply SO3. I'm not doing anything. I'm just writing the name as I see because it is a covalent compound. Sulfur is a non-metal. Oxide is a non-metal. Nitrogen is a non-metal. Oxygen is a non-metal. Okay? So we don't need to balance the charges. We only need to write the prefixes. Dinitrogen tetroxide should be N2O4. Iodine heptafluoride will be IF. Hepta is 7, so it's 7. Boron trifluoride would be BF trifluoride, so it's F3. Now carbon monoxide, it is simply CO. Mono means 1, so there's only one oxygen. Carbon dioxide would mean CO2 because it's dioxide. Again, covalent compound, you need to use your prefixes and you don't need to balance any charges at all. Alright, so that's about how you name all ionic and covalent compounds, okay? Now pause the video and try to fill up this table, okay? Sodium chloride, sodium hydroxide, sodium nitrate, okay? Try to fill it in like these. And pause it. And afterwards, you can check the answer in the next few seconds, okay? So the answers are now here. Now try to see how many you got right, which one confused you, okay? Go back and then try to follow the same methods. It will definitely work out. Alright, and we also need to know how to write the names by looking at the chemical formulas. Now pause this video right now and fill it up on your paper first. Alright, so these are your answers, okay? I hope that you got it all right, okay? And that's about it. That's how you name any ionic or covalent compounds. If you got this right, you are most likely able to name every chemical compound that you will see in IGCSE Chemistry. I hope this video was useful as usual, and I will see you guys again next time.